Hey everybody, it's Professor Davis here from ChemSurvival.com and the YouTube channel ChemSurvival. And today I've taken down my sister's artwork, which is usually on the wall of my office, so that I can show you something using my model kit without anything in the background there to break it up. I'm going to talk to you about something called a cyclohexane ring flip. You've probably heard about this in your lectures already. Now, to show you this, I built a cyclohexane ring out of a Darling model kit. Now, I don't call it that because I like it, actually. Here it is. I call it that because it's actually called a Darling model kit. In fact, I really don't like them. I don't think they're good for much, except for showing cyclohexane ring flips. So I dusted mine off and took it down so that I could show this to you today. Now, let's get a good look at this cyclohexane molecule here. So you can notice that if I get this in the chair conformation here so that you can see it, I have a situation where I have four coplanar atoms, and then I've got my ottoman here and my footrest down here. And when I do this, the way that I built this model, you'll see that I have red axial atoms. And I've put all of my equatorial atoms around the perimeter of the ring in white. So we have red above and below, and we have white around the perimeter. But I can do something called a ring flip to this model. And all I have to do to effect a ring flip is to take my ottoman and make it my footrest. Take my footrest and make it my ottoman. Let's watch what happens when I do that. You ready? Here we go. Ring flipped. Now that the ring flip's complete, check that out. All the white substituents are now in the axial position, and all the red are now in the equatorial. So this process of ring flipping doesn't break any bonds, so it's just a conformational change. But it results in a wholesale interconversion between axial and equatorial. All my axial atoms become equatorial, all my equatorial atoms become axial. And I can do this back and forth as many times as I like. I can ring flip back again, now I have my red in my axial. I can ring flip again, now my white are back in the axial position. So this molecule can do this as many times as it likes, as fast as it can. Now, what's going to become really interesting is when these positions are no longer just hydrogens as in this model that I built. Eventually, those positions are going to become all kinds of substituents, and they'll have an effect on how much time each cyclohexane ring spends in this conformation versus this conformation. So it's very important to understand. So to get started, I recommend that you take a look at our video on ring strain at the YouTube channel ChemSurvival. And that'll get you started on why it is that cyclohexane is so common in organic chemistry. And then once you've got a good grip on that, you can start working through your ring flips and how it is that these axial positions and these equatorial positions can affect the populations of the two conformers when they're substituted. And that's all for now, guys. Good luck with your cyclohexane ring flips. I'll talk to you next week.